So we'll do some problems based on this bandwidth extension. You see here, an amplifier has a mid-band gain of 125 and a bandwidth of 250 hertz. 250 kilohertz. So nothing is mentioned about feedback. So this represents your capital A and bandwidth without feedback. If any term feedback comes, then these two will be AF and BWF. But since there is no word relating to feedback, this should be without feedback. So capital A is 125 and BW is 250 kilohertz. They are also given if 4% negative feedback is introduced, find the new bandwidth and gain. So beta is 4%. They are saying 4% negative feedback I am going to introduce. They're asking us to find the new bandwidth and gain. So you know the formula for bandwidth F with feedback, it is A1 plus A beta into original bandwidth. A is 125, beta percentage. So apply, you get the bandwidth as 1.5 megahertz. You see, previously without feedback it was just 250 kilohertz, but now it has become 1.5 megahertz. So your normal amplifier has become a broadband amplifier. It is going to work for a very long range of frequencies. And the gain without feedback, gain with feedback, AF is given by A by 1 plus A beta, 125 by 1 plus 125 into 0.04, so you get 20.83. You see, from 125, it has reduced to 20.83. Okay, so it is reduced to 20.83. So the gain reduces, bandwidth is going to increase. And how to verify this AF value is correct? See, we have seen that AF is approximately 1 by beta. AF is approximately 1 by beta. Beta is 4 by 100. So 1 by beta is 100 by 4, so it is 25. Approximately it should be 25. The actual value is 20.83. Is it clear? So this is the effect of feedback on bandwidth. You can clearly see how the bandwidth is enormously increasing from 250K to 1.5 M. And gain is reducing from 125 to 20.83. Okay. Next question: if the bandwidth is 1 megahertz, find the feedback ratio. The reverse. They are saying the new bandwidth is 1 megahertz, find the beta. So they're asking what value of beta can provide a bandwidth of 1 megahertz. So BWF is given to be 1 megahertz. BW is same, 250 kilohertz. A is also same, 125. We are going to find the new value of beta. I am representing it as beta dash. Clear? The same question. First, directly we are finding out what is the bandwidth of, with feedback and the gain with feedback. Now, reverse. For a particular bandwidth with feedback to be 1 megahertz, what should be my feedback factor? Beta. So it's the reverse type of question. Okay. So BWF is 1 megahertz as it is given in the second subdivision. BW is 250 kilohertz. We'll take it as it is. A value is 125, and I'm going to find out what is beta dash. So simple, all parameters are known, only beta dash is unknown. So you can have the parameter involving beta dash on one side. You can take other things to other sides. So 1 plus 125 beta dash will be 1 into 10 power 6 by 250 into 10 power 3. You get 4. Or beta dash is going 125 beta dash is going to be 3, or beta dash is going to be 3 by 125. It is 0.024, or I can say it is 2.4%. I always express beta in terms of percentage. So here the beta is 2.4%. So when the bandwidth for 1.5 megahertz, the feedback factor beta is 4%. So for 1 megahertz, if the bandwidth is reducing, then beta will also reduce. So it has become 2.4% from 4%. See, these kind of problems will be asked in your exam, which will relate your understanding on what is the extension of bandwidth when you are going to apply negative feedback to an amplifier. These problems will hardly take few minutes to complete, and you might get full marks upon getting correct answer. Rather than writing pages full of theory, these problems will save your time, and you can also score more marks in these problems, provided you know the concept of how negative feedback is going to enhance the bandwidth of an amplifier. This is one type of problem where you will be indirectly asked to find what feedback factor will be required to produce a new bandwidth.